Hello, everybody. Can you hear me? I believe so. So this is Stefano Tempesta, and this is a Dear Azure webinar about AKS, the Azure Kubernetes Service. We speak today about security more specifically. All right, then. So let's get started. I have a few slides to present, and we'll go through some best practices. Very briefly, an introduction about myself. As said, Stefano Tempesta. I'm based in Australia, in Melbourne, more specifically, as a CTO for a company called SXIQ, stand for Southern Cross. And I'm a Microsoft Regional Director, MVP on Azure, certified trainer. I do a lot of things in the Microsoft tech space. And I believe this is the third or fourth webinar for Dear Azure. So thanks, Kasam, for the opportunity to collaborate together. Always a great opportunity to speak to you all and share the latest around our beautiful Azure cloud. So more specifically, let's go into the content for today. Briefly, a few concepts around the AKS cluster, just to set up the terminology for everybody. But I don't want to speak too much on how to configure a cluster. I'm giving some of these concepts for granted. If they're not, please write in the chat your question. I'd be happy to take questions as soon as I notice in the chat, pretty much. But today we want to focus around the security. So I want to talk about access and identity to an AKS cluster, obviously, specifically to pod and nodes, and security concept for running applications inside a cluster. Not just concept, but best practices. Best practices for authentication and authorization, and for security overall of your cluster. At the end, you want to make sure that whatever application you're building in containers, in AKS specifically, it is secure according to the guidelines that Microsoft provides. All right, let's start from some basic concept. Now, I'm assuming that everybody is familiar with Kubernetes. As application development moves towards a container-based approach, the need to orchestrate and manage your resources is very important. And Kubernetes is the leading platform that provides the ability for reliable scheduling of fault-tolerant application workloads. What does it mean? Well, it means that Kubernetes in Azure, so the AKS, the Kubernetes services offering in Azure, simplifies container-based application deployment and management. And if you have done already Kubernetes before, you know that this is a platform that is evolving very quickly and provides an application to run containerized format, and the associated networking storage component can all be managed in AKS as well. So the focus is on the application workloads, not the underlying infrastructure components, and Kubernetes provide a declarative approach for deployment and an API for management, for programming the several components. All right, so what are these components that you see on screen now in this diagram that are all managed in the Azure cloud? We can summarize a Kubernetes cluster into two main components. One is called a control plane, and the other one, node. So a control plane provides the core Kubernetes services, all the orchestration, and the application workload. You have the scheduler, you have the controller manager, the API server, and so on. Then, in the nodes, you run your actual application workloads. So there are some terminology that is quite important to understand, that you see on screen there related to an etcd, that helps to maintain the state of the Kubernetes cluster and the configuration, a controller manager, which oversees all the actions for replicating pods into the different nodes. Now, all of this is fully documented on the Kubernetes website. I will be here talking probably for the next hours just to go into the detail of configuration of a Kubernetes cluster. At the end, I will point you to some resources so that you can, if you're new to Kubernetes, if you're new to AKS, you can see how to create a cluster in Azure, how to configure AKS, how to deploy application in multiple nodes. For now, what I want to do is shift a bit the attention on the security part of it, and obviously, if you need to get back to the core concept in a later stage, just let me know, and I will try to help you out after this call, and obviously with the right resources that are available online. So let's move now more into the security conversation, and let's clarify one point around some terminology again, because these are specific to running nodes and pools of nodes in Azure. Some other cloud provider may have a different terminology. So when in a few slides I will be speaking around security, I will be referring to a kubelet, to a proxy, and obviously a virtual network in Azure. So this is specific to Azure. In AWS, in the GCP, the concepts are similar, but they may have a different name. So let's clarify from an Azure perspective. If you want to run your application and all the supporting services into Kubernetes, you need a node. And a cluster has one or more nodes, this is quite obvious, which is basically made of different virtual machines that runs all the Kubernetes node components and the container runtime. So a kubelet is the sort of the agent from a Kubernetes perspective that processes the orchestration requests from the control plane and the scheduling and running of these requests from the container side. Then we have the networking component, which is an Azure virtual network. This is handled by the proxy, the kube proxy for each node. So you can understand that from a security perspective, this proxy is quite critical because it handles all the traffic in input and output, so egress and egress traffic from the container to the rest of the network. And the proxy also routes, yes, as I said, network traffic, but also manage all the IP addressing for services and pods. So proxy is really the key component to protect them, and we'll see how to do that. And then we have a container runtime, which is the component that allows a containerized application to run, interact with network, storage, and files in general, and so on. All right, okay, so we have identified the structure of a node. We have identified what are the components that we need to protect, specifically the proxy and the virtual network. So let's go more into the detail on how we have to do that. And let's start from an access and identity perspective. Now, there are different ways to authenticate within a Kubernetes cluster. In the interest of time, I'm going to focus on the integration with Active Directory, and I'll mention the other authentication methods. Again, get back after this call or ask any question now if you want to know what are the other ways of authentication. I'll mention that in a moment, but for now, let's focus on integration with Azure Active Directory, which in my opinion is the most secure and the more popular if you're using Kubernetes in Azure, obviously, and the one that I use the most. I do a lot of deployment of Kubernetes cluster for my customers, and they are in Azure, and they all integrate with Azure AD. This is what the customer wants, because all their account, all the service account, all their resources are already profiled in the Active Directory. So there is no need to introduce another way of authentication. But I'll get back on that in a moment. So Active Directory integration. So the security of a cluster is of a Kubernetes cluster with AKS can be managed completely in Azure AD. And that is quite important if you're doing Kubernetes in Azure, because Azure is a strong identity management, multi-tenant, obviously cloud-based, and provides directory services, application access management, identity protection. There is a lot that you can do in Azure AD. And with Azure AD, you can even integrate with on-premises. I don't know if many of you know, so I know many people I speak to, many customers I speak to know that you can even integrate on-premises identities and make them interact with an AKS cluster. So you can provide a single source for account management and security. You don't need to have a different identity providers. All right, so with Azure AD, with an Azure AD enable or cluster, AKS cluster, you can grant users or group of users access to a Kubernetes resource within a namespace or across the cluster. First of all, you need to obtain what is a kubectl configuration context. Then you run an instruction that a command to obtain the credential of the user. And when a user interacts with the AKS cluster, they are prompted to sign in using the Azure AD credential. So authentication is done completely in Azure AD. Passwords are encrypted and stored in Azure AD. There is nothing that is stored inside the cluster itself. This approach provides a single source for user account management, password, credential, everything is in Azure AD, and the user can only access the resource as they are defined by the cluster administrator. So if the cluster administrator grants you access to some specific resources, you as a profile user in AD can have access to the specific node in the cluster. So you're basically separating access and identity management from the management of the cluster itself. Azure AD will take care of that. What if you don't want to do Azure AD? Look, that's okay. There are different other ways of doing authentication and identity management, also native to Kubernetes itself, because obviously, as you know, Kubernetes is an open source. It's not, it doesn't belong to Microsoft, it doesn't belong to Azure. You can do Kubernetes in every other cloud, in every, even in your own on-premises infrastructure. So what if you're not running on Azure, or what if you don't want to use Azure AD, or simply you can't use Azure AD with your cluster, with your customers? Well, Kubernetes has service accounts, and a service account is managed in Kubernetes itself. The credentials are stored in Kubernetes as a secret. I'll talk about secrets a bit later. So you can authenticate and authorize access to pod, communicate with the APIs, and it's a normal identity management for inside Kubernetes itself. Some people use it when they don't have an external Active Directory. My recommendation is it is secure, yes. It is scalable, no, really. because you're managing cluster and identity all in one single place. Active Directory will help in the different way. You also have another way of managing identity, which is a role-based access control. This provides a sort of a more granular list of actions that the user can perform based on the role. So instead of being attached to the user, that user belongs to as a role, and the permissions are granted at role level. So in that way, you create roles to define permissions and then assign those roles to users using a role binding. And I will show you in a moment how to do that as well. There are some best practices for securing roles and role bindings. This is a bit more popular than the direct Kubernetes Secret, because instead of having individual by individual associated with permissions to operate inside the cluster, you have a role. And a role is a bit more dynamic, because if a person leaves the organization, you just have to deactivate their account, remove from the role, and still everybody else in the role remain with the same permissions. And the other way around, if there is someone new that joins the organization and you want to assign to a specific role with some permissions, you just have to create a role binding without making any other modification to permission set and so on. But I'll get back on role binding in a moment. So keep in mind for now that these three ways: the native Kubernetes using Secret, the role-based, and the Azure Active Directory. Okay, now there is a bit of talking here, so let me see how we can make it more interactive in some way. So if you have any questions at any stage, probably this is the right time to ask. To protect your customer data as you run, your application in Kubernetes, in AKS, you want to keep in mind the security of your cluster, as we said, especially around proxy and virtual networks. There is some components around storage. Probably not going to touch too much security around storage today, but if we have time, I will definitely do that. Now, Kubernetes includes security components as a network policies and secrets. And Azure, more specifically, then add on top of network policy and secret, also some other components related to security, mainly for orchestrating or managing security from a cluster perspective. So these are all in the list that you see on screen: master component security, node security, cluster upgrades. So let me touch briefly on one of them now, and then we go more into the details in a few slides. So in AKS, master components are part of the managed service provided by Microsoft in Azure. Each AKS cluster has its own single tenant dedicated Kubernetes master that provides API server, scheduler, whatever we have seen in the picture before. So that is for each cluster, you have this master component for each Kubernetes tenant, basically. And this master is managed and maintained by Microsoft. You don't touch it; it's their responsibility. Microsoft looks after the security of these master components. Now, important to know, by default, out of the box, the Kubernetes API server uses a public IP address and a few fully qualified domain name. So use a DNS that is fully qualified. You can control access to the API server, And you can do that using a role-based access control and Azure directory, but not using the native Kubernetes secrets. Okay, so it's quite important to know, because this master component is not part of the Kubernetes framework itself, platform, is a component that is added by Microsoft in Azure to oversee all the clusters. So then is Microsoft to control it, is on a public IP address, fully qualified domain name. You can control only the access to it using Azure AD or the role-based control model. Node security. Now, this is quite important. You remember in the slide before when I mentioned the kube proxy. The kube proxy is within a node, and that is the key component to protect. So what kind of security we are discussing here? This is security of a node. What is a node? It's a virtual machine that you manage and you maintain. Typically a Linux machine. So this Linux node run on Ubuntu, is a very optimized version of Ubuntu distribution, which is using the Moby container runtime. There may be also some Windows Server nodes that are, I believe they're currently in preview in AKS, but personally, I never done it. I never run a container on Windows. I only do Linux. When an AKS cluster is created for the first time, all the nodes are automatically deployed using the latest security updates and configuration. So from a node perspective, when you create a new node, you always get the latest updates. Now, in Azure, you also get some benefit of having a managed AKS, right? So a managed platform. So the platform automatically applies all the security patches to all these nodes, to all these Linux distribution. And it does on a nightly basis, every single night, whatever your time zone is, depending on the region where your cluster is deployed. On a nightly basis, if there are updates to Linux, they will get updated straight away. And it's all done automatically for you by Azure. If a Linux security update requires a host reboot, that reboot is not automatically done. Okay, that is important. You can manually reboot the Linux nodes, or a common approach is to use cured. I'll get back on that. Okay, I have another slide to talk specifically around cluster updates from a security perspective, or operating system updates actually using cured. And I don't know if you know, but cured is this sort of a daemon for Linux OS, specifically optimized for Kubernetes to do this reboot in a way that guarantees high availability. What else to say? From a networking perspective, so talking about networking security, nodes are deployed into a private virtual network subnet, so they don't have a public IP address assigned. You have SSH, so if you want to do some troubleshooting, some management, you can access through SSH. And this SSH access is only available using internal IP address. So you see, the best security practices are already applied. So no public IP address on your node, only SSH access, and only from an internal IP address. So if you're doing something different, probably you're not following the best security practice. This is what Microsoft recommends to do. And this is what you get out of the box anyway. So if you're changing something, it's because you are intentionally doing this. And then there is some security around the storage. I probably will not go too much into the details, but just very briefly, Storage for an AKS cluster is done using Azure Managed Disk, and these are disks that have full high availability, near real-time backup. They are premium SSD, so that means that you have the best quality possible. And data that is stored on this managed disk is automatically encrypted at rest, and these disks are also replicated across different data centers. So within the same region, you may have multiple data centers, and you have a replication of this disk. Okay. What else to say? Yes, Kubernetes Secret. This was the last point that I have on my list here. And I mentioned before Kubernetes Secrets in the context of identity. It's not only used for identities. So secrets are used to to inject sensitive data into a pod, whatever is this sensitive data. Is an access credential, is an identity, or simply some application keys. You can control these secrets through the Kubernetes API. And when you define your pod, then you can inject the secrets and attach the secret to the specific pod. And secrets are only provided to nodes that have a pod that requires this secret. So you cannot just assign the secret randomly. You need to configure a pod that requires this sort of a secret. And what else? And as a consequence of this, so if you have assigned a secret to a pod that requires to operate with this secret, and then a pod on a node that requires a secret is deleted, also the secret is deleted from the node itself. And that's it. At least this is what I have in my notes that I want to share with you around nodes. In general, from my experience, the use of secrets reduce the sensitive information that is defined for example, in a YAML manifest. Sometimes you enter some of these sensitive information like password, like any credential in general, or keys, API keys, into a YAML file, into manifest. Instead, the recommendation is to use these Kubernetes secrets and attach to a specific pod. So not just any pod, but just only the pod where the key is actually, the secret is actually used. Okay. No question for now. Let me double check the chat. So I don't see any questions, so I'll carry on. Let's go more into the details. So one thing that I want to mention is Curd. So Curd is one second that I don't see. Here we go. So Curd is this open source daemon that is available on GitHub, and it runs basically it monitors each node for the presence of a file, indicating that a reboot is required. And then all the reboots are managed across the cluster using the same process for a cluster upgrade, which prevents a cluster to going offline completely, and instead guarantees this sort of high availability. Look, I'm not the best expert of Cure, to be honest. So the best way that I can recommend is to go on the website that you see on screen, which is on GitHub anyway, and get some more information. I use it simply for making sure that when I need to reboot a cluster, and it happens very occasionally, but sometimes there are some critical security updates that do require a reboot. They are planned in a proper way using this little tool, this little demo using Qt. And another URL that I want to share with you, here we go, comes on screen now, is around the secret. As you can see, the link is to kubernetes.io, so to the docs of Kubernetes, which means, again, this confirms one more time that secrets are a native capability of Kubernetes. This is not something that is in Azure. This is not something that Microsoft has introduced. So if you're using Secret, you're using native capability of Kubernetes, which give you that flexibility of being a vendor independent. So if you're moving your Kubernetes cluster from Azure to another cloud provider, the secrets come along inside the Kubernetes pod. But if you're using the Azure Active Directory, for example, and then you're moving to another cloud provider, obviously you lose the integration with Azure AD. All right, so links are on screen. I said slides will be shared, so feel free to take the URL right now from doing a screenshot, or just wait until the slides will be shared and the recording of this webinar as well. Moving along, let's go now into some of the best practices. Okay, so we want to I want to share with you some of best practices that Microsoft recommends. So these are coming from Microsoft itself. I'll share the reference at the end, so you have more in writing, also something more to read, and also from my personal experience, because obviously I've done containers for a few years now, and I observe what customers want, what they prefer. Microsoft obviously makes some recommendation, and I have another side, or maybe the same side, or a different experience, and I'm just sharing this with you. So let's start again with Azure Active Directory. I already mentioned that is the preferred method for authentication from my experience. Some best practices, so how to optimize the integration and the security. So when you deploy an AKS cluster with an Azure AD integration, you are centralizing identity management using Azure AD, obviously. So any change in user account or user or group account is automatically updated in access to the cluster itself. So use roles or use role bindings, so basically the role-based access control, as we discussed before, to define user and groups. And the recommendation is set the least amount of permissions needed. It's better to have more roles associated to a person rather than a big roles with a lot of permissions. So always follow the principle of the least amount of permissions needed when defining a role to access, or even directly to an individual in AD. If you're a developer, I'm pretty sure most of you are, or in general, someone that owns the application that is running on Kubernetes, you need access to multiple resources, right? So you don't want to be limited in what you can do. Now, because Kubernetes itself doesn't have an identity management that controls which user can interact with what resources, what you typically want to do is to set multiple roles into AD and provide the AD integration directly in Kubernetes. So this is done using roles, and also what another concept is called cluster role, which defines access to all these resources. And then basically you bind the role to a user in Active Directory. So the sequence is as a developer. So step number one, you authenticate in Azure AD for the first time with your username and password. You get an Azure AD token, and as a developer, you perform an action using this token as a reference. So for example, you can create a pod and use this token as a way of authenticating your request. Kubernetes validates the token against the Azure AD. And then, because the token is assigned in a unique way to you, to your identity, Kubernetes knows which group you belong to. So at that point, the role-based access control method enters into action. All the cluster policies are applied, and the action is confirmed or not, depending on your permissions. So this request is basically successful, is accepted or not, based on the validation of your permissions against the Azure AD, whether it's individual or a group. Okay, this is the sequence of these numbers from authentication number one, token number two, send a request to Kubernetes services number three, and so on. Okay, so this is what I would typically recommend doing it. Now, an extension to this, so using Azure AD as identity management, is to use a role-based access. So a role-based access is a control that is based on roles and on role bindings. So use RBAC, the role-based access control in Kubernetes, to define the permissions that users or groups have for all the resources defined in the cluster. And then create the bindings that assign permissions that are required to execute a specific action. Again, think always of the least amount of permissions required. So as an example, on the left-hand side, you see the YAML script to create a role that grants full access to resources in a namespace called finance-app. And on the right-hand side, you see the role binding that is created to bind that Azure AD user in that namespace with a specific level of access. In this case, full access to the finance app namespace. Okay, so this is a role-based access control along with the role binding. Okay, now I mentioned before around of Azure AD as an external system for managing user authentication, user identities. You can use the same approach also for pod identities. So the best practice here, the guidance for using pod identities with Active Directory, is not to use fixed credentials within pods, as they are potentially at risk of being exposed. Instead, use pod identities to automatically request access using Azure AD. So pod identities are sort of meant to use within a pod and container images only, and not outside of that. So from a process perspective, this diagram that you see on screen again, as a developer, create a pod that use a managed entity to request access, in this case to SQL Server, but it can be any Azure resources. So the cluster first create a service account that can be used to map the identities when the pod requests access to the service, and then the node management identity server and the managed identity controller, which are deployed and and relay on the cluster itself, they basically accept this request and the process the request for each pod. As a developer, you deploy a pod with a managed entity, and then you can access that pod after you get basically validated by the node management identity server. It's a bit tricky. And this is something that is still in evolution. So basically, pod identities is an open source project, has a limited support in Azure, and it's still something that is growing interest in the community. The problem that it's trying to resolve is basically that managed identities for Azure resources, instead of being implemented inside as a secret inside the Kubernetes platform itself, they are managed as identity that are still associated to a pod as a Kubernetes secret, but they are entries inside an Active Directory. It's sort of a way of Microsoft entering into the secret space using Active Directory. So the best practice is sort of using NMI, and which is the node management identity server in Active Directory. From my personal experience, I haven't seen this approach being largely used. It's more of Azure AD for individual or role identity, and Kubernetes Secrets for specific access to credential keys inside a pod itself. But I just wanted to mention, because you will find some reference to pod identities using Active Directory, and sometimes it's good to know what are the options available. And one of the last slide I have is around cluster security. And there are a few things to keep in mind when securing a cluster. And of course, you understand this is one of the most important things that you can do when you want to secure your AKS deployment. I already mentioned before, so I'm repeating this for the last time, to use a combination of Azure Active Directory and role-based access control to control access to the API server. So in this way, you can secure AKS in the same way as you secure any other application that you run on Azure using the same Active Directory. Now, more specifically, the Kubernetes API server provides a single connection point for requests to perform action within a cluster. So you want to secure and audit the access to the single connection point for the API server. You want to limit access and again provide the least privileged access permission that is required. And although this approach is not only for Kubernetes, you will do this sort of approach for any other service in the cloud, but it's specifically important for an AKS cluster that is isolated within your Azure tenant itself. What else to say? Sorry, next slide. Here we go. What else to say now to secure container access to specific resources? You want to limit access to actions that containers can perform. Provide the least number of permissions we already mentioned, and avoid the use or root of privileged users. Now, in the same way that you should grant access to user and groups the least number of privileges required, also for containers, it should be limited to only the action and processes that they need. And to minimize the risk of any attack, you don't want to configure application containers that require escalated privileges or root access. Now, keep in mind that even if you apply all these guidelines, a Kubernetes environment is not completely safe from any, any hostile activity. So you need to apply some additional security features, like pod security policies, but also AppArmor. And AppArmor is basically a more fine-grained role-based control that limit the action the containers can perform. It runs at Linux kernel level, is part of the operating system itself, and the good news that is always enabled, at least it is enabled by default. So basically you create some profiles in AppArmor that restrict actions such as read, write, execute at kernel level. You can control whether you can mount a file system, for example. You can restrict access to some location. You can isolate containers from the underlying node completely. So this is one of the extra level of security that you want to consider, probably only in a production environment, to completely isolate your Kubernetes pod from the rest of the container itself. And this again is another good practice that is not specific to Azure. This is inside Kubernetes, inside actually Linux operating system. So it's more about a Linux best practice. And one of the last recommendation that I want to mention is obviously to keep your Kubernetes up to date. Stay current on new features, bug fixes, update regularly your Kubernetes version to the latest one. So using the command that you see on screen, the AKS get upgrades, you can check the version that are available for your cluster. And then using the command AKS upgrade, then you can run the upgrade itself. Now, this upgrade process safely shut down a node at a time, schedule pods on remaining nodes, and then deploys a new node running the latest operating system and Kubernetes version. So this is the way to guarantee high availability of your cluster, and obviously upgrade to the latest version. Last slide of the day is to keep also your operating system up to date. And I've already mentioned this before, using Cured as this daemon for checking that an update is available. Cure run on a specific node, verify that a file exists, reboot required, and if this file exists, then it will schedule the reboot of the different pod using the same principle, the same approach described before. So one node is drained, basically, so is shut down, removed from the cluster, and the new one is brought in, and high availability is guaranteed for the entire cluster. So again, Cure is the tool to use for managing these reboots when a security update is required for a specific node. That's it, I believe. I'll point you to some of the resources that you can see on screen. First of all, there is a learning path that is really the ABC of Kubernetes. If you're starting to see Kubernetes for the first time, you want to start from there. Then there are some more documentation around the Kubernetes service, the security part of it that you can see on Azure directly, some case studies if you're intrigued to see how Kubernetes and AKS more specifically is being used around the world by customers, and obviously start for free with a trial in Azure and get your hands dirty with the AKS before going into running any application. We are at the end. So thank you very much for listening, for watching. Any final chance for some questions? I'd be happy to take them now. Otherwise, again, I'll be available. You will find me on social networks, and then the slides and recording will be available in the next days for download. Thank you very much.